你们期末考试考了吗？差不多。已解锁，请启出话筒。You guys have midterm tonight? Tonight. That case, maybe I'll make announcement on Friday then. If more people coming on Friday, maybe today people go back studying. Uh, but I already made an announcement on midterm on Moodle. Maybe I'll say again on Friday, and then I will release the quiz 2 result on Friday as well, and then we can discuss about the quiz result. Um, Another thing is I'm quite happy that people come and ask me about recording. So sorry about that. Last recording there's no audio because there's some technical issue. I plugged in the USB cable and I forget to plug up. Then the sound are just coming from the USB, which is nothing. So we'll try to avoid that in future. So I guess it's on now the mic. So supposedly we should have audio today. So if there's anything, please feel free to email me. Yeah. think, think I think about three of you messaged me about the Teams. I know about the audio recording. Yeah. So midterm audio. Yeah. Any other thing you want to feedback to me? Okay. So I guess the second half of the material is getting maybe new to you or a bit harder. So please feel free to stop me during the lecture. Okay, so I don't hope that you just how to say mm, just get lost or confused. Okay, without help. So please remember that we are ready to help here, but you're gonna use your chance appropriately. Use your chance appropriately. Okay. Uh, if no question, how about let's start? Let's resume from substitution rule. Okay, we'll do a few more exercises before we go to the next part. Let's pick up from substitution. Okay, so let's recap what we have done. Um, so let f prime equal to little x, okay, capital F prime equal to little f here. Or if you like, we can add in the variable. So we define that the definite integral of little f x dx is this. Okay. Or if we want to write a better notation, maybe to remind you, f prime is just the dx of x. Okay. So in other words, we can extend, we can write in a better form to remember maybe the integrate of a derivative function fx is fx. So this is by definition. Okay, so what did you observe here is you do differentiation and then you do integration, you get back the same function. It's like cancelling. You do nothing to the function. Okay. We have the other way around, right? Do you still remember we have the other way around? D dx integration. X is also fx. We also have this. What's this? What does this call? What's the theorem? What's the theorem? You should remember this. What's this theorem? Fundamental theorem of calculus. Okay, first fundamental theorem of calculus. But there we are defined using a definite integral here. Okay, we need some domain to occur here. Okay, first one is by definition. Okay, second one is only true if we integrate the proper region in the proper integration domain. Okay, so you can think of this derivative and the integral as a inverse of each other. You learn inverse in linear algebra, right? Okay, F inverse is identity. Then you go back to yourself. Or F inverse F is F. Okay, but slightly different of this direction here. You need an integration domain. Above is just definition. Okay, so using this idea, we will learn the substitution rule. Okay, so last time I didn't tell you how we get the substitution rule, but maybe I can show you now. So if you still remember what is chain rule, and chain rule gives what? UV prime equals to, sorry, this is a product rule. Chain rule give what? FGX prime equals to, sorry, where should I put this prime? The whole thing prime. Okay, FGX prime equals to F prime GX. F prime applied on GX times the derivative of f. Or we could write it in the dy dx form. I'll write this in. So I should say that I should differentiate with respect to gx. Maybe I use a color to show you that this gx is a new variable. You can think of gx equal to y by gx like that. Okay. Okay. Then what do we have? We can apply integral on both sides. Okay, we can apply integral on both sides. Let's apply integral on both sides. And let's find integral on both sides. Okay. So you can see that on the left-hand side, right, you are integrating a derivative. Okay, so from just now, what do we know from just now? From just now, we know that this is simply just equal to f. So on the other side, we have the integral of f prime gx and then g prime x. So this is the substitution. Okay. 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 Okay, I think in your substitution rule, right, you get some extra C here because this is your empty. This is what we call the empty derivative. Okay, but last time I asked you to use a better notation, right? Use a better notation to do this. What's the better notation here? I asked you to rewrite this. So maybe we can let y equals to gx such that we get f of y integrate of f prime y. And then what's the rest here? The rest here actually is dy. Okay, because if we let y equals to gx, then dy is equals to dy over dx of dx. Okay, this one is from this is from the chapter differential. If you still remember, we talked about the delta y, delta x, and then dy dx is the distance between the tangent line, your original point. Then if you do this derivative here, d over dx gx dx. So this is exactly g prime x dx. Okay, so this is a more applicable way to substitution. Substitution. Okay, so we're gonna use this setup here. Okay, so first you identify what you want to substitute. Okay, so first step here, identify. Then define substitution, and then second step here, compute the differential, and then the third step here is do substitution. Okay, any questions so far before we go into example? Just three steps. Okay, find what function you want to substitute. Second, compute a differential. Third, do the substitution rule. Okay. Okay, with the step, and then we will try one example. Okay, let's try one example that we haven't tried last time. How about try this? Okay. So there's a product of function you want to integrate here, and we're trying to use a substitution rule. Okay, so there are really few choices here, right? Either you want to sub u equals to sine 2x, or you want to sub u y equals to cos 2x. Okay, you can try. Okay, you can try which one is useful for you. But what I'm gonna do now is let let y equals to sine 2x. Okay, and then second step, we'll compute what is the differential. Okay, so how to differentiate this function with respect to x? Okay, you only know how to differentiate sine x. Okay, so sine 2x is a composite. Okay, so if it is a composite, you need to use chain rule. Okay, so if you use chain rule, what you get is 2 cos 2x. Yes. Okay, so maybe I write a bit full. So dy equals to d of sine 2x over dy times uh, times dx. Yeah, like that. Okay, so then we can use substitution rule. Or integral of sine x 2x cos 2x dx here becomes what? Becomes y to the cube. Okay, and then cos 2x dx. Okay, it's a bit it's a bit away from what we had here, but we can rewrite this such that dy over 2 or 1 over 2 dy is equals to cos 2x dx. Okay, so we can replace the cos 2x dx as 1 over 2 times dy. Okay, but can you notice that we already make it into a polynomial function to integrate? Okay, so do you know how to integrate a polynomial function? Y cubed over 2. How to integrate? Huh? Y to the what? Want to try? Huh? Try. Otherwise, you make mistake in the exam is worse. Who want to try this? How to integrate y cubed over 2? Or maybe you can pull the 1/2 out first because you can always pull the scalar out. So what is this? So to integrate, to find this, you need to ask what's the function that differentiate to y cube. Okay, what's the function that differentiate to y cube? So you need to do reverse of differentiation. So what's the reverse of differentiation? So during the differentiation, you will bring the power down and then the power minus 1, right? So reverse meaning you need to power plus 1 and then divide by the. Okay, so what do you get? Try. Yeah, y the power 4 and then over 4. Yeah, so if you do differentiation, you put the 4 down and then 4 minus 1, you get y cube. Okay, so this is the integral you get and then plus c. Okay, so then what do you do next? You just substitute back your x. I mean, substitute back your y, which is multiply it together, so such that I get 1/. Okay, so far so good. Question? Any question? Yes. What do you want to do to it? What do you want to do to it? Which one? This line? This line? At the end, this one. Okay, yeah. Do you still remember that our integral is linear? So we can take out the scalar and then we do integration. If you leave it inside, it's fine as well. It should be just y to the 4 over 4 times 2 is the same. It's the same. Yeah, it is the same. Right? Right or not? Yeah, because if you differentiate, your 4 and 4 will cancel and then you're left with y cubed over 2. Yeah, it's the same. So that's why we are allowed to pull it out first. Okay. Okay, it's the same. If you leave it inside, you do integration, you pull it out, you do integration, it's the same. So that's why we say that integral is linear. Okay, it's the same. Okay, how about we try maybe one more? You want to try this yourself? Right? Should I give you some hint here? Tangent is sine over cos. Yeah. So you can try with cos, you can try with sine, see which one is better. Okay, let's try. So what have people tried here? What did you try? You substitute x, sine x, or substitute cos x? Cosine. Okay, so let's try cosine. So let y equals to cosine x, and such that if you find the differential, dy equals to d over dx of cos x times dx, okay, which is minus sine x dx. Okay, then we can use substitution rule, integrate tangent x dx equals to integral of sine x cos x. So you can see that we substitute everything in terms of y, we get integral of 1 over y negative and minus 1 times dy. Everyone okay with the substitution? Okay, so in this case here, you are integrating 1 over y. So whose derivatives is 1 over y? Okay, it is actually ln of absolute value of y. So this is a negative. So you make sure that you start with a x variable. You need to end with a x variable. Okay, so negative ln of cos x. Any question so far? Any question? Okay, so if you want to check your solution, right? One way to check your solution is go and differentiate this. Okay, differentiate this. Do you get back tangent x or not? Okay, go and differentiate this. Okay, maybe you can do a sanity check here. Uh, every question you can do the sanity check your integral. So if you differentiate minus ln cos x here, do you get back your tangent x? Okay, go and check this. Okay, if you want to check your integral is correct or not. Okay, question so far? Question? No. Okay. Should I check for you or you can check yourself? You want to check yourself or I can check for you? No, I offer an offer to you. So if you say yes, it's okay. If you say no, it's okay also. Huh? You want? Okay. Okay, sure. So do you know how to differentiate this minus ln cos x here? What's the basic function here? There are two of them, right? Ln x and cos x. But then this is a composite. So if you want to differentiate composite functions or revision, next Friday is midterm. Right? So what do? You need to use the chain rule. Okay, so you need to use the chain rule. Okay, so for you to use the chain rule, obviously you also do something like substitution, right? Okay, so you need to, for example, let y equals to cos x, and then dy dx is equals to what do you call this? Minus sine x. Okay, so if you differentiate this, this is equivalent to d on dy of negative ln y times dy dx. But if you differentiate negative ln absolute y, last time we proved that, okay, this is negative of 1 over y, and then dy dx we computed is negative sine over x, which is equals to sine x over cos x. Sorry, I throw away your constant. Are you happy? Because after differentiating is 0. Are you happy or not? Is it okay? This constant here is just 0. So what you left with is, I mean, constant after differentiation is 0. Okay. After derivative is 0. So what you get is also tangent x. Okay, so can you compare how similar is the chain rule to this substitution rule here? It's very similar actually. You need to find a substitute, and then one of them you just find the derivative. The other you need to find the differential. But to find a differential, you also need the derivative actually. So it's very similar. So it's like in first step to each other. Okay, question. Any question? Okay, no? Okay. Let's do one more question and then we will go to the next part. This thing is very important. Okay. Later on in the next chapter, we'll keep using this integral here. Okay, so this is very important. So I should show it to you. And this question, right, is a little tricky. It's very tricky. Okay, because if you just expand it out, right, it's just 1 over cos x dx. Okay, so if you do substitution, you maybe just pick u equals to cos x, right? And then maybe du equals to minus sine x dx like that. But there's no sine x for you to substitute here. So should you like put your sine x to the other side to replace your dx? This is not good. Why is it not good? Because the point of substitution is you want to change to a whole new variable, but then you need to put your x back again, so it's not good substitution. Okay? So this question is a little tricky. Okay, it's a little tricky here. So instead of doing that, we will do something like, so this one doesn't work, okay, because we're gonna get back our x again after substitution. So this is bad. Okay. If it is good, we should turn it to a new variable already. But now we have to stay with x again. So this is not good. Instead, what we're gonna do is consider the following. Okay. You don't need to copy. I just listen me first. I will provide you see what I say makes sense or not. So consider u equals to sec x plus tangent x. Okay. So you might think that why I want to look at this. Later, I'll show you why we want to look at this. Do you know how to differentiate this? I think you need to use a bunch of quotient rule, okay, because u is equal to u is equal to 1 over cos x plus sine x over cos x. So it's a differentiating a quotient, so you need quotient rule on both sides. So then if you do it, then you will get something like negative sine x over, sorry, negative of sine x over cos x squared plus cos x. You can verify this minus sine x squared and then over cos x squared. Okay, this seem a bit daunting here, but if I simplified it, you will just get secant x tangent x plus secant squared x dx. Okay. Well. Maybe I can substitute a little bit. Sorry, factorize, I mean. So let's factorize secant x here. Okay, secant x times tangent x plus secant x. Okay. So can you see the relation what I'm going to do here? There's a secant x here. There's a secant x plus tangent x here. So I try to substitute that secant x plus tangent x. So there's no secant x tangent x inside the integrand, right? So I'm gonna produce it. Do you still remember how to produce the function? We're gonna multiply the function by 1. Okay, so meaning I'm gonna slip this in. So I'm gonna slip u into it. I'm gonna integrate secant x dx equals to the integral times secant x plus tangent x over secant x plus tangent x. Okay, I'm gonna put this in. Then, what did you see here? This secant x factor, right, multiply to the numerator. Okay, this is exactly the differential I have computed just now. Okay, this is exactly the differential that I have computed just now. I can replace everything by du. Okay, and then at the bottom here, I replace by u. Okay, so in the end, it becomes a very simple stuff as du over u. okay, which is integrate 1 over u d. But we know that what's this, right? This is ln of absolute value of u plus c. Okay, so this is everything in terms of ln absolute value of secant x plus tangent x. This is a bit tricky. Okay, so I'm not sure how you can think of this. Unless you are very familiar with the derivative of secant. Okay, otherwise I don't know how you can come up with this. I mean, the whole point that when I try to prepare the lecture for integration, there's all sort of technique. Okay, so if you can find your way to integrate, that's okay. Okay, no need to like follow exactly like what we teach in class. Maybe there's a lot of way to do one question. You understand or not? Just that this one, maybe I want to show you. Okay, I want to show you the pattern of the derivative of secant. That's it. Okay. Otherwise, in the next subsection, right, you will see all sort of technique that I also cannot imagine from myself and the spot. Okay, you just need to do a lot, and then you remember the pattern. Oh, I think I can use this, or I think I can use this. And then if it works, it works. Okay, yeah. There's no like a particular way to do it. Okay, for most of the integration. Okay, make sense? Okay. Okay, let's continue. Okay, then we also have substitution rule for definite integral here. So meaning we not only compute the integral, we also can evaluate it. Okay, we also can evaluate it. Let's do maybe two questions from here. I guess it will be easy to do it. Okay, so note that once you do the problem is like this. So you try to integrate uh, the integrand that look like fgx times g prime x here, but the integration domain is starting from a to b, which is giving the range for your x. But then if you do the substitution, you already change your x to some function in u. And so you need to restate your integration domain in terms of u. But how do you restate it? You just sub your x equals to a back to your substitution to get your new u. Okay, this is the point here. Okay, so okay, if you listen already, so let's try it. Okay, let's try it. So let's try this question here. Okay, so for this question, what do you want to substitute? You can try anything that works, but we're going to try this. So let uh, y equals to 2x plus 1. Okay. Do you prefer I use that notation? You want to use gx or fx here? Okay, maybe I just let's follow the following the above statement notation first, and then later I will show you another notation for y1. Okay. So let's show you this notation. So if I use the above notation, right, I need to tell you what is my f. So my f is square root x, and then my u or my gx is equals to 2x plus 1, such that, oh, let me see, is this a scammer? Hello? Hello? Yeah? Bagi? Hello? Yeah. Oh, yeah. Okay. Okay, bye. Okay, bye. Okay. Okay, bye. Okay, it's not a scam, it's a Shopee code. Right, I try to get some quotation and then they could try to call me so that I get they get my business. Wait, where's my good note? Okay, so let's continue. So in this case here, so what is g prime x here? So g prime x is 2, and then what happens to my new integration domain here? So when x equals to 0, my g0 becomes 1, and then when x equals to 4, because we are integrating from 0 to 4, my g4 becomes 9. So let's fit this everything in. And let's fit all this in. So let's see if we can fit it. So if we want to integrate from, so again by substitution rule, here we integrate from 0 to 4, square root 2x plus 1 dx. Okay, so what we get here was uh, integrating from 1 to 9 of fu. What is fu here? So fu is just square root of u, right? Okay. But the point here is we don't really have g prime x here. Okay, so because 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 our g prime x here is 2. Okay, ideally there should be a 2 here. Okay, but then we will divide it by 2 of du. Is anyone confused here? Why we divide by 2? Anyone confused here? Why we divide by 2? Anyone confused? Okay, because um, yeah. Okay. Uh, and then what we get for the rest, we just integrate this. So we get 2 over 3 u 3 over 2. Okay, and then integrating from 1 to 1. So if you compute this, this is 26 over 3. So we are dividing by 2 because if you follow this pattern, right? If you follow this statement pattern here, what you should get is integrating from 0 to 4 of square root 2x plus 1 times 2. And then dx. Then this is equal to the integral from 1 to 9 of square root u du. Okay, but if you notice that in our question, right, there's no 2 here. There's no 2 here. So this 2 have to be divided. Okay, so you need to multiply half to both sides. Okay, you want to see that. So that this is the real question that we are getting. Here we are integrating square root 2x plus 1 instead of 2 times square root x. Okay. Okay, let's do one more. Okay, let's do one more using the y notation. Okay, let's do one more using y notation, and then I'll let you do one exercise together. Okay, let's do this one. Okay, let's use the y notation. So in the y notation, right, we don't really care about the fx because if you already set what is y, then it is clear what is fx already. Okay, so we'll let y equals to this big jump here. The first thing we will try to substitute is the denominator if you want to ask about the technique. maybe you want to try and substitute your denominator here first. Because if you substitute your numerator, then the denominator, there's no guarantee that you can make it into something simpler. But once you substitute something in the denominator, then you will make into one variable. Okay, then you will be integrating some reciprocal function. Okay, so if we do this, then we'll get that dy equals to 2x plus 2 dx, okay, which is 2 times x plus 1 dx. Okay, so then we can see what is our new variable here. When x equals 0, new integration domain limit here. So when x equals 0, y is just 6, 0 plus 0 plus 6. And then when x equals to 1, y becomes 1 plus 2 plus 6, which is 9. Okay, so if you integrate by substitution rule. So how do we replace this? So we have our new integration domain here, so which is 0 to 9. And then we replace the denominator by y squared. How about numerator? Okay, how about numerator here? So your dy equals to 2 times x plus 1 dx, right? So you got the x plus 1 dx already, but you got the extra 2. So you need to throw it to the other side. Okay, like what we discussed just now. So you are integrating 1 over 2 y squared. Okay, so how to integrate this? Okay, so to integrate this, you should get minus 1 over 2y, and then integrating from 0 to 9. Like that. Okay, and then what do you do next? Well, you just substitute. So what do you get? Minus 1 over 2 times 9 plus 1 over 2 times 6. What is this? What's this? Maybe you can try negative 2 over 36 plus 3 over 36, which is 1 over 36. Okay. Actually, there's another way. If you don't want to do this substitution, right? Maybe. Okay, I think I shouldn't teach you that way. Okay, I shouldn't teach you that way. Because it's logically not true. Because we already changed variable, we should keep the 6 and 9. But maybe you can try something out is if you put y back to x squared plus 2x plus 6, and then you just integrate from 0 to 1. Okay, if you substitute back in the x position, and then you just use the x integration domain. But don't write 0 to 6 here. You'll be wrong. Okay, please don't do that. But my claim is so this is my claim. Maybe you can try and calculate yourself. My claim is you can do this calculation from 0 to 1. Then I think you can do this calculation. My claim is this two is the same. Okay, but don't write like integrate from 0 to 1 dy to the exact. This is like a hybrid substitution. Cannot. This is wrong. Okay, you cannot keep your integration domain from x and then do integration on y. Okay, please don't do that. If you write things in y, everything in y. In x, everything in x. Okay. Then my claim is these two combinations is the same. That's it. I didn't say where this comes from. I just said these two are the same. Okay. Any question so far? Question? Oh. Okay. I let you try one question, and then we check answer, and then see if it works or not. Which one should we try? Okay, maybe I let you pick. You want 5.45 or 56? Pick one. We can do together. You want to do trigger or you want to do long? Trigger or long? Give Aaron chance. You want to do trigger or long? Pick one, pick one. You must pick. This is the rule. You must pick. Long, ah? Okay. Okay, let's try long. I give you this is quite short. I give you 1 minute. See if you want to substitute x, or you want to substitute long, or you want to substitute 1 over x. There are a few choices here. You can try it out. So if you try, you fail, then this will build your intuition. Okay, next time when you see this question, you will quickly think, oh, which one I want to substitute. Okay, what have people tried? What did you substitute? What did you try? Want to try? The black shirt guy. What's your name? What's your name? Your name? Brian. Huh? Okay, what have you tried? No? Maybe try on the spot. Which one you want to try? You have to try, otherwise your exam zero. Write nothing. You don't want to try. Okay, I don't want to answer. 很有性格. Yeah, y equals to what? Try one. 1 over x? Ln x? Yeah. How about you? You want to try what? Just try, just try. Never mind, it's okay. I can make mistake with you now, but I cannot make mistake with you in the exam. Try one. 选一个。选一个。没有，你不可以选这样久啊！你选这样久啊，你读书啊，你就是花5分钟在那边乱想吧。你就是要试吧。You just have to try. Okay, you cannot think for 5 minutes when you do revision. This time is wasted. Why not? You just try wrong mistake, make mistake, and then learn, make mistake, and then learn. You understand what I said? No? Don't just think about something useless. Okay, because this is I tell you I sit with my student and do revision. I watch them do revision. I see how they study, and then I realize that it's very inefficient. It's very inefficient. So you read half and then you go and play game, and then you read half, you play game. You haven't even finished compute a example, and then you go and play game. You understand? So you have to manage your time, manage your revision. Okay, okay. Choose one function. Log x. Okay. So we just try log x. If it is successful, then successful. Okay, if not successful, and then we think of a way to fix it. So if we try log x here, if we differentiate dy over dx, we get 1 over x dx. So this is our new differential here. And maybe we can see what happened to our integration domain. So when x equals to 1, okay, y equals to ln 1, which is 0. And then when x equals to e, y equals to ln e, which is, okay, so this is our new integration domain here. So let's try a substitution rule, see if it works or not. Integrate 1 to e ln x dx. Okay, so then this question is very nice actually. So if you can see that actually it's split into ln x and then dx over x, okay, which is very good. So you get 0 to 1, new integration limit, and then ln x is y, dx over x is dy. Okay, very good. It's just integrating y. Okay, so you get y squared over 2, integrating from 0 to 1, which is 1 over 2 minus 0, which is 1. Yeah, good. Then proceed, do another exercise already. Okay, yeah. Okay or not? Anyone try other substitution? Anyone try other substitution? Maybe you try x. Maybe you try 1 over x. Anyone? No? No. Please make mistake. I want to say, please make mistake. Okay, once you make mistake, you learn. Please make mistake. Don't fear mistake. Okay. Okay. Any questions so far? Any question? Any questions so far? Before we take a break. No. Okay. Let's break until 11:03.哪一个？对，因为这个是关于一个 x 的 limit integration，但是我已经变成 y 了嘛，所以我已经从 x 变到 y，所以我的这一个 value 也要变到 y，但是变到 y 的过程就是你要 apply long 的 x。这个就是 x，对呀，这个是 y，你变对对对。嗯对，要怎么设？你就试哦，那怎么样不能设定？你就算哦，看你能不能够算出东西来，因为它有时候会卡住，就是来假设我用，比如说这题啊，我用 y 等于 x 嘛，OK，假设我用 y 等于 x，然后我跟着同样步骤跑，dy 和 x like that，then 你就可以看到我能不能够 substitute 完整这个东西，就是说来，我能不能把全部变成 y 的一个形式，是嗯，then 如果 x 等于一的话，y 就等于一哦，因为 y 等于 x，x 等于一的时候，y 也等于一了。y 是在 dy 的，and then x 等于 y，这样我就可以变成 y，但是这个 ln x 我还是搞不定啊，我搞不了，所以意思说这个 substitution 不是这一步要上哪一步？就这个这一步啊，这一步是因为我这一步是什么 x，这个 into y，这里是 x 的东西，这里应该要就是 y 的东西，因为你已经把 variable 变成 y 了，所以我的这个里面应该要在这个，但是 x 跟 y 的关系是被这个 substitution 控制。Yes，
在考试用这个做法可以，这么这样子，这个是不是那个FX，然后
yeah，understand， 但是没有问题。
没有。
但是如果你能够把那个substitution 写出来更好，你就写在旁边就好。
哦，
y 等于1
嗯
u and then Okay, let's take attendance. 西和 got 乐天、瑞阳、若石、施曼、一南、玉涛、玉涛、玉涛、玉涛那边，一泽、丽文、瑞妍、泽汉、加来、古加来有吗？哦，对了，嘉诚、嘉怡、齐军、王齐军，哦，一清、俊逸，位置，季俊逸，哦，sorry，miss you，相思、意林、雷意林、雷意林，not here I guess，冰镇 got，嘉坛、浩源，yep，温琪、汉翔、俊杰、新阳、万达，got，新月、玉衡，got，一田，yep，冰城、浩然，那个是浩然，Desmond，OK，Tommy got，冲毅，冲毅 disappearing，Inje got Skopagani here. Yeah. Arthur seems like not here. Jose got Hisham. Yes. Yeah, yeah. I already taken for you. Yeah. Your classmate remember you. That's your classmate. Huh? Yeah. What? What? Can't find your seat. Okay, Hisham. Hisham? You? Okay. You're not here on Friday? You here on Friday, right? Or maybe Hashim is not on Friday. Hashim here. Hashim, you here on Friday? Oh, why I got the exam here? Okay, I need to fix this. Okay. Madia. Oh, Madia not here. Okay. Aaron, Brandon got Alicia got Gunakanti, Margaret got Hassan, Javed here or not? Yep. Gabriel, Daniel got Daniel. Oh, this is Daniel. Daniel, yeah, saw you. Right. Gabriel, is Gabriel here? Okay. Jeffrey also here, right? Okay. Jeffrey is Purity, Chen Fan not here. Yating, Yating here or not? Yating not here. Hu Ye not here. Hong Liang got. Okay. Good. Okay. I guess everyone is back. Alex. You. Okay. So I still want to stress here. So the integration limit there or the integration domain is about x. So it follows what the variable you are integrating over. So if you change to y, make sure that you use the relation, okay, between y and x to switch the integration limit. Okay, so make sure you switch it. Please don't write like integrate from 1 to e of y dy. So this is not right. And then what else I need to think? Okay, so another thing is maybe you ask a question, which substitution I should do. Okay, there's no which substitution you should do. It's what substitution it works. Substitution that works. So for example, I try out something that doesn't quite work here. Okay, let's say if I substitute y goes to x, maybe I want to substitute, change your denominator, but y goes to x really did nothing, right? It really did nothing because you are not really changing anything here. But if you look at the substitution here, it is true that there's something that you cannot make into y as well. Okay, I don't know how to fix this long x here using this substitution. Yeah. So this would say that substitution doesn't quite work here. Okay? Substitution doesn't quite work. Okay, so this is a bad. We say that this is a bad substitution. Yeah. Okay, so you should try. You should try it out. Okay, you should try it out. There's no general method to tell you, oh, this is good, this is bad. Okay, if it doesn't work, then it's bad. Okay. Yeah. Okay, try is very important. Please try. Please try. Maybe this is a problem with students why they don't want to start do revision because they don't know how to try. They would think that, oh, I need a recipe, I need a manual. Step 1, step 2, step 3, step 4, step 5. I want step 1. No step 1, I don't want to start. So let me tell you what's the step 1. Step 1 is try. All step is about try. Please try. Okay, please try. Step 1 is try. Okay, so step 1 I gave you already. Yeah, please try. Okay. Next, symmetry theorem here. So this symmetry theorem is very convenient. Okay, so if you have integration limit that's from minus a to a, so meaning it is symmetric across the y-axis. Okay, so minus a to a here. If you know that your function is even means what? Fx equals to f minus x. So meaning across this y-axis, value of f is the same. Okay, is the same reflection. Okay, along this y-axis here. But if it is odd function, it's also reflection, but in the other way. Okay, which is fx equals to f minus minus of f minus x. Okay, so if it is positive on the right hand side, it will become a negative on the left hand side. Or if it is a positive on the left hand side, it will become negative on the right hand side. Okay, so if you try to do integration, what happens here? If it is even, this integral here can be split into two parts. Okay, from 0 to a is the same as 0 to minus a. So you just take 2 times the integral from 0 to a is enough. Okay, because two sides is the same. How about for odd? So one side is positive, one side is negative. They have the same f value, so they will cancel out. Okay, so meaning no matter what f I put here, as long as it is odd, and then the integration domain is symmetric along the along the y-axis, then you will get 0. No need to compute, just say 0. Does it make sense or not? Should I prove it to you? I prove it to you. Can you give me a negative odd function? I guess y goes to x, right? Yeah, the easiest one. Okay, maybe you can look at y goes to x. Maybe see how striking result is this. Okay, so let's look at x. So fx equal to x, is it odd or not? So how to check? This is a chapter 1 thing, right? So make sure you know how to check. F minus x become minus x, which is minus of, uh, which is what? Let me see, is it correct or not? So fx equal to minus x, and then this is f of, I'm doing something weird here, equals to minus fx. Okay, so this is imply that fx equals to minus m minus x. Okay, so f is odd. So if you try to integrate, let's say from minus 2 to 2, right? So there are two pieces of rectangle here. So you can use the geometric method to check, right? Can you use the geometric method we learned last time? Okay, if you use the geometry method we learned last time, is the triangle on the right hand side is half times 2 times 2, okay, which is 2. And then the bottom is half time minus 2 the height and the width 2, which is uh, minus 2. Okay. Or if you want to use the integration method, okay, if I use the integration method here, the definite integral, I mean. Okay, so what do I get here? I get x squared over 2 evaluate from minus 2 to 2, which is 4 over 2 minus of minus 2 squared over 2, which is 0. Okay, makes sense. You just see some arithmetic miracle here. You see arithmetic miracle here. Supposingly, this square, right, will make everything into positive. But there's a arithmetic miracle here because we say that the uh, upper limit here have to minus the lower limit. So you are forced to have a minus sign here. And then luckily they cancel. Okay, makes sense. Makes sense. So this is a miracle such that the whole thing will work here. Okay, so let's use this method to compute. All right, so we need to check. So this, not that, uh, not that, the integration limit here from minus pi to pi is symmetric along the y-axis. Okay, so we can see whether it's odd. How to think about odd function? Maybe like this. We can think about if it is an odd function, right? This is even, or it is an odd function. This is just example. This is not the function itself. So maybe you can use this example to remind yourself what is an even function, what kind of odd function you could have. Okay. So let's check. Also, what is the cos of negative x over 4? Do you know any trigo identity or not? You know trigo identity? Cos minus x equals to cos x. You know this trigo identity here? Okay, so exactly this trigo identity is telling you that telling you what? Telling you that this function is even. Okay, because cos is even. Because cos x is even. Okay. So this trigo identity in particular is telling you that cos is even. Okay. So for this kind of trigo identity, right, there's a list in your textbook you can refer to. If we need you to use it in the exam, we will give you the formula. Okay, we'll provide you the formula. Okay. So since this is even, so by symmetry theorem, instead of computing from minus pi to pi of cos x over 4 dx, what we could do is we just take 2 times the integral from 0 to pi. Just take half of it and then multiply by 2. So is everyone okay with integrating this function here? This is a composite, right? Okay, so we should use the substitution rule. Okay, so we could use the substitution. Use substitution rule. So you can tell me what's your substitution. Y equals to x over 4, and then dy become y over 4 dx. Okay, and then our limit also changed, right? So how do we change our limit here? So when x equals to pi, y become pi over 4. When x equals to 0, y become 0. Okay, because the relation between x and y now is y equals to x over 4. So by substitution rule, we get 2 times integrate from 0 to pi over 4 of cos of y, and then dy equals to 1 over 4 dx, right? So it becomes 4 times dy. Okay, because we can rewrite this as 4 dy equals to dx. Right? Dx becomes 4 dy. Okay, so we just do this integration. Integrate cos become sine. Okay, sine y. And then integrate from 0 to pi over 4, which is 8 times square root 2 over 2, which is 4 times square root 2. Okay. Any question so far? Okay, so we have used symmetry theorem, we have used substitution rule to help us to do integration. Yes, question. Where? Which one? Which line? First line? First line, you mean this line here? Okay, and then which one you want to ask about? The first cos? X over 9. X over 4, sorry. X over. Any other question? Can follow? Okay, the point here is I want you to train your listening. So in my class, right, you try to listen, follow my argument. Okay, if you want to practice, you can go back and practice, because for different people, practice time is different, you know. For example, do you play sports? 运动，有没有运动？ Do you play sports? 对吗？有。I play sports. For example, I play badminton. I play badminton. But I'm not good in sport since when I was young, because if you look at me, do I feel like I'm the one that holding book every time? Okay, maybe in during primary school, I just study. I don't involve in sport a lot, and my body coordination is different. I mean, it's not good. So during my university time, right, where I have more times, so I can go and play badminton. I even train for badminton. You know what? How many times I spend? Like morning time, right? 7 to 8, I will go to the badminton hall and then do practice, because I train. So I got exercises. Like I give you mathematics exercise. So I was given exercise from my coach. So I have to spend. But for others people, for my friend, they no need to train, but they play better than me. You understand what I say? So this kind of exercise time is different vary from people to people. Maybe you need to spend 2 hours to do exercise. Maybe that person only spend 1 hour. But this one depends. But in this class, right, you should at least listen to what I say. If what I say makes sense or not. If don't make sense, you can question me. And then I answer you. You question me, I answer you. Okay, and then until you understand what I say, you go back and digest this piece of thing. Okay, don't do the other way around. Don't try and digest the thing first. Try and listen what is that thing first before you digest. So people tend to do it the other way around. Without knowing what is this, already start and digest already. Then you might digest the wrong thing, you know. That's the point. Okay. So if anything I said is not clear, right, you just point it out. Okay, maybe you say, oh, He's saying that part I think wrong. Okay, wrong. So why wrong? So we discuss or debate, right, wrong or right, wrong or right. Or if you right, then I make correction. If I right, then you need to follow me. That's the way how people communicate. Understand? Okay. So this part is this. How about next part? Maybe we do a odd example and then I will let you try one example. So let's try this example here. Okay, again, this integration limit here -5 to 5 is symmetric. Uh, I would say across 0. Because if what I'm talking about here is 0 and then you go 5 to the left and then you go 5 to the right. Then we need to check whether this function is odd or even or not. So let's check what is minus x to the power 5 and minus x squared plus 4. Okay, which is minus x to the power 4 and then x squared plus 4. So this is easily see that this x squared, x to the 5 of x squared plus 4 is actually is so this means that by symmetry theorem, this integral should be 0. Okay, because on one side of the x-axis is positive, on the other side is negative, so they will cancel out. Okay, another thing is you will tend to ask me what thing I need to include in my exam, right? For the steps. So I try to keep my step as simple as possible, but I also tell you how to get from one line to the other line. This is the principle you need to uphold when you do this calculation here. So why do you care about this? Why? How you go to the next step? Okay, you need to think like that. Once you think like that, you will write like that. If you don't think like that, you won't write like that. You understand what I say or not? Sometimes even if you write that thing down, you don't know what you are writing. This is the point. I don't hope that the university student is like that. University students should know what they are doing. Okay, you should know what you are doing. Okay, you know what you're doing and then you do it. Okay, it's not you do it without knowing what you are doing. Understand or not? You have to know first and then you do. Know, do, know, and do. Know it. Okay, understand? Okay, if you don't know, please don't do first. Otherwise, the consequence you cannot uh, cover. So know and then do, know and then do. Okay. So I try to keep my step minimal. Okay, let's try do one more exercise. Mm, try. How about try this? This is a bit long. I give you 2 minutes to try this. Check whether it's even or odd. If odd, then the integral is 0. If even, then you need to compute. Someone realized that this is a bit tricky, huh? It's not even at all. It's not how. Depend on how you set it. If you look at it individually, maybe you will realize that someone is even, someone is odd. Yeah, try and split it up. You will observe that some of them is even, some of them is odd. But can we split out or not? Can we split out the integral? Our integral is linear, so we can split out the sum. Our integral is linear, so you can split out the sum. Okay, as a whole, it is not even or odd, but part of it is even, part of it is odd. Part of it. I think you can see some even function, right? For example, x to the 4 is even, because if you put minus x inside there, you're gonna still be x to 4. Sine 4 to the x is also even, but if you multiply as x beside it, it will become odd. Okay. And then s cubed is obviously odd. Okay. So they are actually odd part and even part here. Yeah, so they are odd part and even part. So let's split it up like that. Okay, very good. It's good that you observe that as a whole is not even or odd. But if we split it up into the, let's call this part the odd part. I'll prove to you this is odd. And then I split it into the even part. Okay, so not that. So how to prove? Well, we just apply f and g on minus x. Okay, and then g even goes to 4, which is g like that equal. Okay, so they are even and odd part. So the large function here is actually a sum of even and odd function. Okay, but luckily, our integral is linear. Okay, our integral is linear. So we can split out our integral into odd part and and uh, even part. So on the even part, you got minus x to 4. Okay, and then also we know that our integration limit is symmetric across 0. So minus 2 to 2 is symmetric across 0. So the first part here, becomes 0. And then the second part becomes 2 times the integral from 0 to 2, the positive half of x to the 4 dx. Okay, and then if you compute this, you will get negative 2 of x to the 5 over 5. 5. Yeah, it should be 5. And then from 2 to 0, which is negative 2 times 2 to the 5 over 5, which is 64, negative 64. Okay, yeah. Question so far? Any question? I hope I didn't make calculation error. Okay, question? No? Okay, so without compute the last question, maybe you can you quickly check this function is even or odd? Even. So if you put minus x into cos 5x, right? Cos is even, so cos negative x is always cos x. But sine negative x is negative of sine x. Okay, actually sine is a odd, odd function. Okay, it's you see, it's an odd function. Okay, sine negative x equals to negative sine x. But the power is cube of negative, you still get negative. So actually this function is a odd function. Okay. So if it's odd function and then you integrate from minus pi to pi, okay, which is symmetry equals 0, then this integral is 0. Okay, try and write it out. I will provide you a solution. Okay, so it's odd. The function is odd. And the integral is 0. Okay. Okay, any questions so far about this about this odd even symmetric integral? Any question about it? No? Okay, so far so good. Okay, in that case, then we'll go to chapter. Eh? Is that chapter 6? Oh, I haven't copied the chapter 6. Okay, let's do the chapter 6. Start with chapter 6. We'll be slightly ahead on our schedule because the day on midterms, right? Actually, it's our lecture day, Friday, right? So on that day, 2 hours is for exam, right? So meaning in the morning, we'll only have 1 hour of class. So there will be no 3 hour class on that next Friday. And then I think we will pick from 10 to 11 to meet, so that we don't meet at 9 o'clock. Is it okay? So next Friday, not this Friday, next Friday. The exam day Friday. We only meet 10 to 11. Okay, I will make announcement again. I think I made announcement on Moodle already, but this Friday I'll say again. So this Friday is 9 o'clock, not 10 o'clock. Next Friday is 10 o'clock. Only one Friday because that 2 hour we use for exam. So on that day, maybe we can do some revision. Okay, you can do some textbook question and then you come and ask. Or if everyone is on top of the material, then we can also continue with new stuff as well if you want. If not, you bring a lot of questions here and then we can do it together on next Friday. But this Friday, we will still continue with the normal teaching. Okay, so let's look at the application of integration now. So now we want to compute area between curve. So previously, you compute area between curve and x-axis like that. Okay, but now we're going to be more general. We will compute area between curve, maybe the other curve like that, and then we want to compute what's this area here. Okay, so this is about this section. Okay, so let's start with the part one. So part one is just region above the x-axis. This is what we have seen in previous chapter. So if f is continuous and non-negative, so very important here is we only care about non-negative function first. If it's negative, then we have other treatment. So if it's non-negative, it's above it from A to B. Okay, then we have this R region here. This R region is bounded by the curve and this line of x equals to A and x equals to B, then the x-axis, and then this is the region R here. The area of this region is exactly the definite integral that we have learned last time. Okay, so this f is non-negative. It's very important. Non-negative is like greater or equals to 0. Okay. Positive is strictly greater than 0. And then Negative is strictly less than 0. Okay, and then non-positive is less than equal to 0. So these are the terms you need to familiar with. Okay, then next we're going to find the area of the region under this curve here between x equals to -1 and x equals to 2. So if you want to use the above definition here, is this a definition of theorem? Just call it a statement. You need to make sure that your function is continuous and non-negative. So this is a polynomial function, right? We learned in chapter 1, we know that all polynomial is continuous in every point in R. But then is it non-negative or not? Is this easy to check? Do you know how to check this? Do you know how to check this? You know how to check this? Actually, this check is quite somewhat tedious. Should we? I don't want to use an algebraic way to check. Should I use an algebraic way to check here? Yeah, I think we should. Maybe do you want to play some cheating here? Maybe you can boost your confidence first. So maybe boost confidence, maybe we use GeoGebra. So y equals to. Did anyone know yesterday Cloudflare has some problem? Did you have problem access to some website yesterday? You got ChatGPT is affected. Yeah. I was accessing the symbol lab. Also helped me to compute integration, but I can't because there's some problem with the server of Cloudflare. Yeah. Okay. X to the 4 minus 2x cubed. And then plus 2. Plus 2. Okay, so you can see that where's our integration domain? -1 to 2. So you can see that from -1 to 2 is well above the x-axis. Okay, it's non-negative in particular. But to show this, I think we won't ask you to do in class, I mean in the exam, unless we will guide you step by step. But for the purpose of this class, maybe I'll do it. Okay, so well, I'm gonna split into 3 parts here. Because the simple reasoning is I cannot do all using the same argument. Okay, so we will split into 3 parts. Why this question is different from the question I prepared here? I'm going too far already. Okay, thank you. So let's check this. So I'm gonna split into 3 parts to check. Okay, one is -1 to 0, and then the other one is 0 to 1, and then the other one is 1 to 2. Okay, so we will split into 3 parts here. The reason is I cannot use one argument for all. Okay, so we need to split into 3 parts. So for the first case here, when x is -1 to 0, what is happening here? What's happening here is not that. We need to analyze these 3 terms. What happened to these 3 terms here? So not that x to the 4 is greater or equals to 0. Correct or not? Right? Okay, good. How about x cubed? X cubed is still negative. S cubed is still staying inside -1 and 0. Okay, but the point here is we want -2 of x cubed. So if you multiply negative to the x cubed, what happened? Your -2 x cubed will be greater or equal to 0. So you have something greater than 0 plus something greater than 0 plus something greater than 0. So it's greater or equal to 0. Okay, so y is greater or equal to 6. Okay, so y is equal to x to the 4 minus 2x cubed. plus 2, right? So every term is greater or equal to 0, plus greater or equal to 0, plus 2, which is actually greater or equal to 2. How about in between 0 and 1? Okay, so here is a little tricky. So maybe we can rewrite our y to be x to the 4 plus 2 times 1 minus x cubed. Everyone happy? Yeah, okay. So just now we say that when x is in between 0 and 1, x cubed is also in between 0 and 1. So you are taking away something in between 0 and 1. So at most this is 1, at least this is 0. But 1 minus x cubed will always be greater or equal to 0. Okay. So this is greater or equal to 0. And since x cubed is always in between 0 and 1, or this implies that minus x cubed is always in between minus 1 and 0. Okay. Okay, how about the last part here? Okay, the last part here. Let's see. Okay, for the last part here, we will analyze it like this. So we can rewrite our y to be x cubed, factorize the x cubed, become x minus 2. So can you see what am I doing in all these steps? Actually, we try to move our function near to x equals to 1, near to x equals to 2, and then see what happens to this function here. Okay. So if you do it like this, you want to make sure this y greater or equal to 2, right? You have to make sure, you want to make sure this y greater or equal to 0, you need to make sure that this 2 sum is greater or equal to 0. Okay, so you need to make sure that either this x cubed times x minus 2 here is bounded between minus 2 and 0, or you show that this is greater or equal to 0. Okay, then you will be adding two positive things. Okay, let's interpret this factor here. So if x cubed, what happened? So x cubed will be in between 1 and 8, which is well greater or equal to 0. How about x minus 2? How about x minus 2 here? So we get that x minus 2 will be less than or equals to 2 minus 2, and then 1 minus 2, which is, this is the first one, this is the second one, which is bounded by 0 and negative 1. Okay, so at least it's negative 1. Okay. Okay, so how about the product here? How about the product here? How about the product here? So this will imply that x cubed of x minus 2. So x cubed is always greater or equals to 1. And then x minus 1, x minus 2 is greater or equal to minus 1. Okay, so this whole thing is always greater or equals to minus 1. Does it make sense? Okay, so in this case here, x cubed of x minus 2 plus 2, which is y, is equals to, is greater or equals to minus 1 plus 2, which is 1. 1 is greater or equal to 0. Okay, so it is greater or equal to 0 for all the parts. Okay. Question? Any question? Any question? Sorry? Confused where? Huh? Which part? Yeah. Okay, my argument is you cannot use the first argument. You cannot use the first way to argue using the other range. You can or not? You try? You cannot. My point is you cannot. Okay. So you can see that in each part, right, I'm looking at a different form of y. You understand? Yeah, because I cannot use the first argument to explain the other argument. Okay, so it's convenient. Okay, it's convenient to split into cases so that I can argue differently. Can you see the argument is different? Can see or not? The argument is different. Okay, but they are coming from the same y. Okay? So one thing you can notice across is I'm kind of like expressing y near this point that I'm discussing. Okay, can you see a factor of 1 minus x cubed in the second line here? Can you see the factor of x minus 2 in the third line here? Okay, so we split it in a way such that how to say it is friendly, okay, friendly to this domain we are here about. Okay, make sense? Okay, yeah, okay, okay, good question. So in this case here, so altogether, hence y is non-negative on this region, negative 1, 2, 2. So how to compute the area? We just compute the integral, okay, from minus 1 to 2 of x to the 4 minus 2x cubed plus 4dx. Okay. So I left it for you to compute this. This is just a definite integral. Okay, integrate the problem. Any question so far? Happy? Question? If not happy, sure got question, right? So you should, if not happy, you should ask question. Question? Got question? Okay, I can follow. Can follow? Okay, good. All right. So integrating this, we just leave it for you to do. Okay. Next, we will integrating region below the x-axis now. Okay, so belowing the x-axis, so you need to make sure that your f is continuous and non-positive. So non-positive will be uh, less than or equals to 0. Your function stay below the x-axis, meaning let's draw it. So your function have to stay below it, something like that. X, this is y. From A to B, again, A to B. So the R region here will be bounded by this curve and the line x equals to A and equals to B with the x-axis. This is the below region below x-axis. And the area here is the same as before, but I put a negative sign. Okay? Because it is below the region, then the integral itself actually will give you a negative. So you put a negative to compensate it, okay, to make it positive. Does it make sense? Can you imagine or not? If you use the Riemann sum idea, do you still remember the Riemann sum idea? It's a rectangle. Okay, and then I make the rectangle very small, very small, very small until I get the whole region. Okay, but you can see that this rectangle, the height is negative. So the Riemann sum will give you some negative answer. So I put the negative back to compensate the negative. So to make this positive area. Make sense? Okay. Yeah. Okay, so this area should be positive in some sense. Okay. Okay, so let's compute this. So is it clear that this is a negative, no, sorry, non-positive function on this region here? Is it non-positive or not? This shape, x squared minus 3 minus 4. This shape is a laughing face, right? Y squared, x squared. Is there a negative part? Do you know how to graph this? So simple graph, you have to make sure you know how to graph it. So if I graph y square x square, it's something like this. Okay, x square plus 3 over 3, sorry. So it's a gradient problem here. Minus 4 means what? I shift the whole graph down by 4. There actually there's some non-positive part. Okay, so but the part you care about is from minus 2 to 3. Okay, so actually it's around this part here. So how to show this is negative? I mean non-positive. How to show this is non-positive? Actually, you just need to make sure that this 2 point here will stay in between the 2, 0 here. You just need to make sure that these 2 point here will stay in between the 2, 0 here. Okay. Yeah. Do you know how to find the 0? You know how to find the 0? So we can try and factorize it. So not that. Y equals to x squared over 3 minus 4 equals to 1 over 3 of x squared, which is equal to 1 over 3 of x minus 2 square root 3, and then x minus 2 square root 3. Hey, sorry, x plus 2 square root 3, right? And then x minus 2 square root 3. Okay. So actually on one side is minus 2 square root 3. On the other side is 2 times square root 3. Because this is 0, and then and this is quadratic. Okay, you can show that beyond this minus 2 over square root 3 is greater than 0, and then beyond square root 2 times square root 3 is greater than 0, then you should use the intermediate value theorem to tell you that everything in between here should be negative. Okay. Still remember the intermediate value theorem that we learned last time? It will be in the test. You should take care of it. Okay, so since minus 2 and 3, so minus 2 and 3, and everything in between, okay, is squeezed by these 2 points here. And y is quadratic. Y is quadratic. Then we'll say that y less than 0, okay, on the region of minus 2 to 3. I shouldn't say y is quadratic. Maybe you need to use some intermediate value. Buying intermediate value. Y is less than 0. Minus 2 to 3. Yes, then the area of this function is negative of minus 2 to 3 on x squared over 3 minus 4 dx. And then try and compute this. Okay. Is everyone okay with this IBT thing? Should I write it out in full in the notes? Maybe I try and write this in full in the notes. Okay, to argue why y is less than 0. But if you still remember, the IBT is like if you have some part in the positive part, if you have some part in the negative part, in between you must pass through the y equal to 0. Y equal to 0. This is where the 0 happening. Y equal to 0. Okay. So this line is x-axis, which is y equal to 0. Because you have some function on the positive part, okay, and then the negative part, then you pass through that. Okay. Any other question? Because otherwise, if your function have if it is not If it is not less than 0, right, maybe it comes out a bit. Then you will have more 0, which is not happening. Okay, which is not happening. So you cannot happen. I'll try and write this argument in full. But is everyone okay with applying this area formula here? Okay, once we know that it's non-negative, non-positive, then you just put a minus sign in front of your definite interval. Okay, and then just do the usual integration. Okay, maybe this part is a bit tricky. I'll try and write in full volume in the notes. And then you can try and read it. Okay, any other question? Because we have not much time left. Any question before we break? No? Okay, if not, we'll see you on Friday. And then we will discuss quiz result also on Friday. Yes. Yes. You don't need to bring anything. Just bring a pen and water. Yeah.